very good afternoon. My name is Brian. So thank you for inviting us over here to do the presentation. All right, so this topic we will be talking about online transformer DGA monitoring, dissolved gas analysis, the modern trends in condition assessment. Okay, the content for today, basically, I'll talk about myself as well, okay, a speaker bio, then followed by introduction to the dissolved gas analysis. Then third topic, we'll talk about the fault gases, then moisture in power transformer. Then we talk about the carbon oxide ratio. Then last but not least, benefit of online monitoring. Then, of course, before we end the session, we end with a question and answer. All right. So for GE Monitoring Diagnostic Speaker Bio, so my name is Brian. Thank you. I'm the Technical Application Engineer for GE Monitoring and Diagnostic. I'm stationed in Singapore, taking care of Southeast Asia, Australia, and New Zealand. All right. So I hold a diploma in electrical and computer control engineering. Then I have been in this industry for probably 19, 20 years. Basically, it's all electrical. We talk about switches, turning on the lights, all the way to transmission and distribution. Okay? So, next topic, we'll talk about the introduction to dissolved gas analysis. So, DGA, dissolved gas analysis, then when electrical energy is transformed from one voltage to another, what will be produced? Heat will be produced. Okay, so a lot of time we see that there's two kind of elements. Over here, as you can see, the transformer thermal decomposition, then followed by electrical. Thermal decomposition will look at when there's excessive heat, okay, being generated, then of course, I would say, how should we put it this way? Excessive temperature rise probably is due to insufficient cooling. So when it comes to power transformer over here, so if you have idea on the power transformer itself, there's always a cooling fan, cooling group. So that is where when the oil itself gets too hot, the fan cuts in, bring down the temperature of the oil. Okay, this will improve the insulation. All right, insulation of the transformer. Then of course, when it comes to electrical itself, it can be partial discharge, partial disruptive fault happening inside the transformer. Okay, so when it comes to DGA, we will say that it's an extraction and analysis of those gases for monitoring and diagnostic purposes. Okay, so type of gas evolved, indicate the nature of the fault. Then the rate of increase in the gas indicate the severity of the fault. So of course, when the gas like hydrogen, methane, ethylene, all this is maintaining at a very regular, steady rate, of course, we don't see big fault. But when you see that there's a spike going out, okay, definitely there's something happening inside the power transformer. Okay? So a lot of time, people will ask us, what is dissolved gas analysis? So over here, anyone don't know what is dissolved gas analysis? Oh no, very good. Okay, even though you know, let's put it a very simple way. Okay, something is happening to me. I do not know what kind of illness I have, so I visited the hospital. I went to see a doctor. So first thing first, to identify what kind of illness I have, okay, the doctor, the nurse, they'll draw my blood. Okay, it's a very simple, draw my blood so to identify what exactly the illness is. Am I right? Unless you have any other concept of identify the illness, you can highlight me, okay, enlighten me. So very simple, we'll have the sample, okay, which is the blood test, okay, the blood being withdrawn out from a human body. Then of course we went through the testing purposes. Over here you can see, okay, I'm not studying medical, so I can't really explain all these things to you. So once you have all the tests being done over here, okay, result analysis printed out probably from a printer, others, Okay, so with the result, you can see that your cholesterol, probably your blood level, high blood pressure, low blood pressure, all this will be identified. Blood glucose, all this being identified. So from there, the doctor will come out. The doctor will identify, okay, you have high cholesterol. Okay, what you need to do to yourself, take medication, all this, blah, blah, blah. Then that is where you have all this diagnosis, as you can see. Okay, high blood, normal blood, then all this diagnosis, you can see that probably your glucose level is very, very high. So similarly, doctor extract information from the blood. Okay, then Ross technician, all this, they extract information about the health of our transformer. Just take for example, the transformer itself is a body, it's a human body. So there's oil, transformer oil inside the transformer. So there's a blood inside a human body. Okay, so we want to identify whether the transformer itself is healthy, not healthy. You look at the transformer oil. Am I right? Okay, so next. So over here, very, very simple, talk about the process and the logic. Okay, so sample, as you can see, this is a syringe where you see that this is a transformer oil rather than a red color. So this is the oil. We extract out from the transformer, supply valve, return valve, or the valve that is connected to the transformer itself. So that is those like the vein inside our body. Okay, like when you go and draw your blood, the doctor will just, or even the nurse will take the blood from your vein. So just imagine that the transformer itself, there is, the valve is over here, which is your vein. Okay, you draw the oil out, then from there, extract the gas, from there, extract out from into the testing position, which what you're seeing over here is a PAS technology. Then from there, we identify what is the hydrogen, the methane, the ethane, ethylene, acetylene, all this. So it's like the same as cholesterol, high cholesterol, low cholesterol, good cholesterol, bad cholesterol, all this. Okay, so even the worst case scenario where the gas that we don't want to see is acetylene. Okay, C2H2. So when acetylene is very, very high, probably it's just like, it's equivalent to, probably we detect that this person has a blood cancer. So it's a very, very serious case. Am I right to say that? All right. So from there, the technician, field service engineer, the product subject matter expert comes up representing the doctor. We'll talk about the technology. Then from there, we diagnose, analyze out from this. Okay. I believe most of you should be very familiar with the diagnostic. This is the Duva triangle. Okay. So from there, we identify what exactly is wrong with the transformer. All right. So next topic. Before we go to the next topic, any question with DGA? Taking oil sample, drawing blood, is the same thing? Oh, okay. Oh, looks very serious. I'm a little bit worried. Okay. Or probably the coffee break, everything inside is dissolving, all the gases being produced, right? It's all about DGA, okay? So fault gases. So over here, what is the condition? Okay, the fault condition associated with individual gases. So a lot of time when we come and talk about DGA online monitoring, we always identify 9 gases, the maximum 9 gases. All right. Over here you can see we have the hydrogen, methane, ethane, ethylene, acetylene, carbon monoxide, carbon dioxide. This is the carbon oxide, then oxygen, of course, last but not least, nitrogen. Okay. So which individual gases will identify which individual condition of fault? Okay, so basically while you look at the first one, hydrogen, so every time transformer will definitely have hydrogen. Okay, hydrogen will determine all kind of fault, but you will not know what exactly is the fault. Okay, so in my blood, I realized that glucose level is very high, but that only identified as glucose level very high, but that doesn't identify that I don't have other illnesses. So that's where you have to look at other gases over here. So these are all the wordings. These are all the wordings. Then this is the diagram where you see all the gases. Okay, at what temperature, how much is being produced. When we talk about oil decomposition, all right, versus temperature. So of course, at normal working temperature, you definitely have hydrogen. It's just that how high is the hydrogen? Okay, but when temperature goes higher, and you realize that probably when it reaches ethylene, acetylene, which is the most highest. So when you have the highest, at around probably 500 degrees Celsius, what we are seeing in a transformer? Arcing, electrical fault, right? So which is why over here we mentioned that electrical arcing, oil is more than 800 degrees Celsius, all right? Strong formation of carbon particles, metal melting, all this, all right? So that is the most crucial one where we doesn't want to see from a transformer, okay? So, of course, we have the methane, we have the ethane, then ethylene, then carbon dioxide, oxygen. So oxygen, when you talk about free breathing transformer, definitely there will be oxygen inside the transformer. Unless you tell me that it's a probably totally sealed transformer, then of course oxygen level, oxygen ppm will be much more lower. Okay? So normal paper aging indicate by slow rise in carbon dioxide. Okay? But else if you see that acceleration, and normal aging, okay, you'll be indicated by rapid rise in carbon monoxide. Okay? So, of course, low temperature will indicate hotspot, which is by methane. So when you have methane rises in methane, you realize that probably the oil itself is heated up to 200 to 500 degrees Celsius. But of course, all this is common, is normal. So when the transformer itself is loading 50%, 60%, 75%, heat will generate, okay? So all this gas will be produced, okay? So next thing, C2H4, ethylene, then whereas detection of increasing quantity of acetylene show arcing occurring within transformer. So inside a transformer, you have 3 cores. So very common, you definitely have, when there's very high electrical fault, arcing will occur inside the transformer. It's common, okay, it's common. Although you do have the transformer oil as an insulating barrier, but that still occur, okay? So, rules available to allow for quick and accurate determination of the presence of a fault and the nature and severity of that fault. So now over here we are just telling you that individual gases, okay? So over here, dissolved gas element. So first paragraph over here, this is telling you on that slides that I mentioned previously, which individual gases, hydrogen, acetylene, ethylene, all this. So those are related to which individual fault, okay? But that doesn't really tell you what exactly is the real fault inside the transformer, okay? Unless probably you are maintenance, senior engineer, principal engineer, specialized in transformer, probably by seeing at the physical transformer, you already know what's going on. Or even probably you touch on the transformer body, you already know what exactly is wrong. But then the fact is, we don't have this person existing. Anyone existing? Transformer expert? You can correct me if I'm wrong. Okay? So of course, we will talk about the change in relative gas concentration. So over here you can see that if gas concentration changes indicate that there is a fault, so look at the relative concentration of one gas to another. Okay, to another. So when I realize that probably my hydrogen ppm is relatively high, I know there is a fault. But what exactly is a fault? I need to look at other gases. So all the gases will come out with the diagnostic tools to identify the nature of the fault. Okay? So over here, the diagnostic tools. So all this over here, okay, we talk about online, where you can see that the trending of all the gases, 9 gases, moisture, H2O, all this, looking at this kind of graph, this kind of trending, it's very, very nice. This is a very good transformer. Okay, then of course you will come to gas ratio, then Duval triangle, extra, Then of course you have the key gas. It's based on IEEE 57.104. So all this will identify the nature of the fault. Okay? So far, any question? We're all good? It looks very good. Probably if you are a little bit shy, don't worry. After the session, before the door prize, you can approach me outside. Okay? Ask for my autograph. Perfectly okay. Okay? So next, we talk about moisture in power transformer. So what is moisture? So basically, moisture is the presence of a liquid, especially water. So in chemical equations, engineering, electrical, water is H2O. Okay, H2O. So it's a foundation for life on our planet. Okay, the earth itself, we need water, all this. Then of course it's essential for every living plant, creature, myself. And I want to drink water now. Test. Okay, however, there's one place where you really don't want to see moisture inside, which is the oil paper insulation of power transformer. Okay, so when there is moisture inside the transformer, you actually reduce the insulating strength of the oil paper. Okay, so inside transformer body, you have all the paper, press board, all this element. Okay, I'll touch on it. So over here, you can see that paper and press board elements. So these are all the elements. I would say it's a solid insulation inside the transformer. Okay, when you talk about liquid insulation, what is liquid insulation inside a transformer? Solid insulation is paper, press board, wood structure, core. That is solid insulation. Liquid insulation inside a power transformer is transformer oil. We are all talking about dissolved gas analysis. Okay, it's all talking about oil. Okay, so when it comes inside the cellulose, the main element of paper and press board is cellulose. Okay, cellulose, what does it consist? Okay, it consists of glucose molecule. Okay, we touch a lot on DGA, we touch a lot on blood tests, we touch a lot on glucose level. Okay, so you should be very, very familiar. So over here, you can see that the glucose molecule, this one is working, but when you point onto the wall, you can't see anything, you know. Okay, it's a C6H12O6. Okay, so these are being linked and form a chain. What you see over here, this is the chain inside a cellulose. Okay, and this is the chemical formation equation of C6H12O6. Okay, so when we talk about newly manufactured transformer, okay, all the paper wrapping inside, all the lead, okay, a very good brand new paper is around 1200 dP. So a dP, we call it degree of polymerization. All right, so anything that goes below 200 dP, this paper is severely damaged. The transformer has to be put to a hot stop, no more. Okay, so the chain itself, okay, all this 1200 dP, it's a very strong mechanical chaining everything together, making the strength of the paper. So it can withstand mechanical stress, electrical stress, especially like arcing, all these things occurring inside the transformer. All right, but then, when it comes to intrusion of moisture, okay, solid insulation, craft paper, press board, wood, cellulose product, and of course, dissolved water in the oil, possibility coming from leaking gasket from bushing, radiator flange, the PRD, the pressure relief device, okay, whenever there's a chance, okay, just imagine I have an open wound. Okay, if you have an open wound, you don't take care of it, you don't seal it up, atmosphere, gas, all this enter into your wound. What will happen to your wound? You get severe. Okay, probably it will take a good coverage will take you probably 1 week to recover, but you left it exposed to the atmosphere. Probably going to take you 2 weeks, 3 weeks to recover, or sometimes even worse. Virus, bacteria goes in, you got to maybe, I don't know, bad things. All right. Next. So, what is the effect? Okay, this is something that you should really take note of. Okay, the effect in a power transformer is like irreversible damage to paper insulation. So just imagine you take a piece of paper. You light up a candle with fire. So you put a piece of paper on top. Okay, what will happen to the paper? It's a white color paper. So after that, you'll realize that probably you started to become yellowish, brown, and it's burnt. Okay, but before it's burnt, you take it away. Can you reverse the paper back to white color again? Can you? No. So similarly, for your power transformer, these are very crucial, critical device component which supply all the electricity, aircon, everything. All right. So maintenance, good, taking care of the transformer will last your transformer longer. Okay. Of course, nowadays power transformer utility, we are looking at if the transformer can last forever, better still. But then the fact is, it doesn't really last for that long. Hopefully, it can last like 35 years, 50 years. It's a very, very good transformer. They really take care of the transformer. All right. So, irreversible damage to paper insulation, oxidation and acid level increases. Sometimes we have customer asking us, oxidation happening in transformer oil? The answer is yes. Because, like I mentioned, if you realize that all the gases, the ppm, you see that we have oxygen inside. So when there's oxygen inside the transformer, what will happen? Decomposition, gas decomposition, oxygen comes in, oxidation happen. So all this will happen inside a power transformer. All right? So a lot of time we talk about probably the worst case scenario, it will be arcing and flash over, which is over there. So that's not what we want to see, okay, especially where the following day news come out, explosion of transformer, blah, 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 all this. So accelerate aging rate of insulating material. So talk about the insulating inside the transformer, where moisture enter it, you actually age the transformer. When we talk about transformer, we talk about the insulating material of the transformer. Okay? So, general rules, every doubling of moisture in oil, life of transformer will be half. So take for example, I have a 30 ppm of moisture inside oil. The transformer life could be probably, let's consider 50 years. But in a span of probably 2 months, 3 months, where the moisture actually rises up to 60 ppm, it's double, right? So what is double? 50 years of transformer, it becomes 25 years. Okay? By changing a transformer is extremely expensive. We are looking at probably millions of dollars. Okay, especially you're looking at those, 230 kV, 400 kV. All right? So, I'm sorry, let's go back to... So, more moisture equals to less life. Take note of this. All right. Then next. So over here, we talk about the life expectancy. Okay. Over here, just now we talk about the C6H12O6, the glucose molecule, the strength of the piece of paper, the mechanical strength, mechanical stability, holding on to it. So the reduction in mechanical stability, it will depend on two factors. One, temperature. Okay, excessive load, overloading, temperature will rise. Definitely will rise. Of course, not forgetting about moisture content. All right. Then, of course, a lot of time when we look at the graph over here, dependency of light expectancy of moisture content and temperature, of course, a transformer won't reach 130 degrees Celsius, 150 degrees Celsius. It's very, very hard. Okay, usually it will be around 60 plus, which is very, very hot. Okay, of course, at this point, we will consider hotspot as a worst case scenario. Okay, so moisture and increasing of temperature will produce more moisture molecule. So when there's more moisture molecule, you actually speed the glucose change. So once you speed the glucose change, just now the one that you see very, very long, so once it keep on breaking and breaking and breaking, the byproduct is what? Will be more moistures. Okay? So from there, the more moisture it is, the reduction in insulation of the power transformer. Okay? So, how do we do the measurement by online DGA? So over here, very nice, all the gauges. Feels like Fast and Furious 11 already, where you have all the gauges inside your car. Okay, but this is not. Okay, so moisture in oil. This is being measured in our GDGA device by a thin film of capacity moisture sensor. Okay, so you actually directly measure the relative saturation, which is in percentage, or even we consider percentage in RH, relative humidity. Okay, so from there we actually convert to ppm, parts per million. Okay, using the oil temperature in the monitor, because inside the monitor itself we do have a temperature sensor as well. Okay, so additional modeling such as moisture in whiting paper, bubbling temperature, etc. These are all being supported by the thermal model. Okay, like GE Hydrogen M2X, then followed by the DGA 900 plus. Okay, so over here, moisture in oil, you can see that I have the relative saturation over here. Then I have the oil temperature. Okay, then at the moisture sensor, then temperature of water concentration in oil. Then of course, when you talk about additional modeling, you'll see winding hotspot, hottest hotspot temperature indicated. Okay, all this what you're seeing is what we have to show. Do you want me to end the presentation? Okay, then of course you have the bubbling temperature, then bubbling temperature margin, blah, blah, blah. Then of course, last but not least, not forgetting about remaining time until moisture content in winding insulation is reliable. Okay? Question on moisture? We are all good? Okay, so now we touch on carbon oxide ratio. Carbon oxide, which is carbon monoxide, carbon dioxide, CO2. Okay? So, CO2 and CO is a byproduct of paper aging. If you still remember just now while we are talking about all the gases, all this. So, of course, thermal fault, high ambient temperature, oil oxidations, okay, all this will result in carbon oxide. Okay, so of course, we will take reference from two standards. One is IEC 60599, then the other one is IEEE C57.104. So over here, typical values, 90% of the power transformer, healthy transformer, okay, you'll see that carbon monoxide is in between 400 to 600 ppm. Carbon dioxide will be 3,600 to 14,000. That is under reference of IEC 60599. Then whereas if you look at IEEE C57, okay, that is based on old standards. Okay, old standard, we talk about 4 conditions, condition 1, condition 2, condition 3, condition 4. But we have moved away from here. And it goes into free breathing transformer or sealed transformer, how many years of the transformer in operation. Okay, but in general, we'll talk about the condition where you see that carbon monoxide is 350 for healthy normal operating transformer, then you're supposed to see around 2,500 ppm of carbon dioxide. Okay? So, carbon dioxide ratio. What we see over here, this is a very beautiful graph. Okay, it's looking at carbon dioxide against carbon monoxide ratio, CO2 over CO. So, what you see, excessive heat and moisture will cause irreversible deterioration of cellulose insulation. So a lot of time, if you remember, we keep on talking about that deterioration, all this thing, okay, irreversible, all right. So in the event, chemical substances like all this thermal heat decomposition, oil decomposition, okay, chemical substances will be produced, and especially it will be produced together with carbon monoxide, carbon dioxide, and all this will dissolve into the oil, okay. Then of course, the ratio, where we look at the ratio, CO2 over CO, will actually indicate to you the cellulose deterioration or there's electrical arcing, okay. So over here, of course, I'm not going to go through this. This is the extract from IEC 60599, all right. So if you have chance, you can just go ahead, take a picture if you really want to read, okay. But I'll run it through for you, don't worry. So CO2-CO ratio, this is to indicate the level of cellulose decomposition, okay. Then of course, general rule of thumb, transformer with healthy cellulose insulation, we are looking at the ratio CO2 over CO, which is in between 3 and 11, okay, 3 and 11. So imagine, before you go down, so 3 and 11, take for example, just now the previous one. So take for example, if I have a 2,500 ppm of carbon dioxide, then probably with around 500 of carbon monoxide, what is the ratio? 2,500 divided by 500, which is 5. It's in between 3 and 11. So we consider it's a healthy transformer. We consider it's a healthy transformer, all right? But let's take for example, if I have 25,000 ppm of carbon dioxide with 5,000 of carbon monoxide, what is the ratio? Is it still 5? It's still 5. But is it a healthy transformer? No. So a lot of time, you don't really depend on the ratio, okay? But you have to look into one and another gases to identify what exactly is wrong with the transformer, all right? You can't just come and tell me, hey, Brian, the carbon dioxide ratio is 5. It looks good to me. There's no insulation issue. There's nothing wrong with the transformer. But when I take a look at it, you're having a 25,000 ppm of carbon dioxide, 5,000 ppm of carbon monoxide. It can't be nothing wrong with your transformer, okay? So very simple. Anything, no, that should be the next slide. So over here, we take into consideration ratio falling below 3, most likely is an electrical arcing occurring inside the transformer. Okay, this is identified, okay, being analyzed as electrical arcing. Then whereas if the ratio climbing above 11, okay, we look at probably the aging of cellulose, perhaps by thermal heating, all this. So not necessary if one day you realize that your ratio actually reaches probably 20:1, 30:1, that doesn't mean that your transformer is not healthy, okay? You have to always remember this is just a guideline. It could be the issue with probably cellulose. You always have to take a look at other gases, okay? So oil temperature is crucial, okay? This whole session we're always talking about moisture, temperature, all this. It's similar to human body, okay? Now I'm at probably 35 degrees Celsius, I'm healthy, I am not having fever. When temperature rises, 37, 38, 39, what is happening? You're having fever. It's the same thing as transformer, okay? So, oil temperature is crucial during sampling, okay, as solubility of carbon dioxide will diminish with rising temperature. Okay, so over here, the extract from the IEC 60599 is what I've mentioned about, probably 2,500 ppm against 500, or 25,000 ppm against 5,000. Okay, so you can take a look. Picture taken, photo taken. Before I go to the next slide, all clear. Let's go. Okay, benefits of online monitoring. Before we touch on this, any question on carbon oxide ratio? We are all good? Waiting for the door gift, okay? Let me drink some water. So when we talk about benefits of online DGA, so you can see that constant monitoring of the entire system for incipient faults. Of course, if you look at offline usually we identify as drawing the sample, sent to lab for analysis. Okay, those will take probably some duration, but when you talk about online, you'll be always monitoring. Okay, take photo. So you don't really need to wait for the result, okay, from the laboratory. So over there, you can just straight away identify probably on the device itself under the HMI. Then from there, you can identify all the gases in one glance. Then of course, earliest possible detection, real-time analysis will actually assist probably the maintenance team, the engineering crew, all this, to do the next step of action. Okay, you don't wait for until the lab result comes back and realize, oh, my accident is very high. What should I do? Probably you're wasting a lot of time away. Okay, but like I mentioned, access to data offsite, remotely diagnose incipient fault. Okay, you can take the first action immediately. You don't need to wait for the next visit. All right. So multiple communication methods on online monitor facilitate integration to SCADA and other operation system. Nowadays, substation, all this, we all talk about SCADA, IC 61850, communication Modbus RTU, all this. All right. So powerful modern software tools to store, monitor, analyze data on your transformer fleet. It could be 50 transformer in your fleet, up to 100, no issue. Okay. So online monitoring enables the most effective transformer condition-based maintenance (CPM) program to be implemented, rather than every year once I do a maintenance on a transformer. Then from the result, the analysis data that I collected, I realized that the transformer itself is actually quite healthy. Rather than I do it once a year, probably I can do it once biannual, 2 years in one time, which will really save costs, right? So conclusion, we are a little bit fast, okay? So when it comes to conclusion, the important to monitor DGA, dissolved gas analysis. So DGA, just always remember when it comes to DGA blood test is equivalent, okay? Moisture, carbon oxide with appropriate diagnostic method. Online monitoring provide accurate data. Of course, you have to look at the trending. You have to look at the trending for all diagnosis, okay? Then condition-based maintenance will improve reliability, reduce unplanned outages of power transformer. Okay? So, are we good? Yes, sir. Question and answer already. Thank you.
I just want to ask your opinion, about the online monitoring system for the DGA, because in my workplace, the DGA will be take by in a period of time, 6 months. But you mentioned that the DGA you can test all the time, real time. But how long is how much is the duration between for each time sampling the DGA? And in your experience, already installed, maybe already installed in many projects, actually during the test between each sample, the trending for the gas from the good condition become warning and then become dangerous. It's in a period of hour or day or month. Can you maybe share with us?
Okay, thank you for the question. Very simple, for using the online DGA monitoring. Okay, we look at the frequency. Like you mentioned, if you do offline, probably it's half yearly, one result. So probably next half a year will be one result. So it's very hard to do trending of gases. But else, if you were to go with online DGA, I mean, of course, in the market, you can actually set the frequency to 1 hour, one measurement. So 1 hour measurement, throughout the whole day, 24 hours, you will have 24 measurement. Okay, 24 measurement, it's a lot of measurement, okay? But if you talk about how long the frequency, days or weeks to actually identify trending, if there is really a fault with the transformer, we talk about accuracy, we talk about repeatability, at least probably 12 measurements. So half a day, 12 hours. Okay, I can see a perfect trending on the gases already. Okay, then if you goes to, let's take a look at this one. So over here, if I would have 12 measurement, I can already identify, is the transformer healthy or not healthy? Okay, minimum, let's just take for example, minimum you need 12 measurement with 1 hour set frequency. Every 1 hour, one frequency. But of course, in the event, if I realize that my hot metal gases rises up, then I want to identify in a very short period of time what exactly is the fault in order for me to take another action. Okay, for GE Online DGA, okay, you can actually set 30 minutes for hot metal gases only. Okay, hot metal gases. So 30 minutes. So take for example, if normal frequency 1 hour, for 2 hours I only have 2 measurements. Okay, I mean of course at the third hour later I have 2 measurements. But if you were to go with 30 minutes rapid measurement, rapid mode, so in 2 hours time I will have 4 measurements as compared to 2 measurements. So that is the beauty of online DGA. Rather than if I were to take 1 measurement, take 1 sample, send to this lab, then this lab come back, tell me this result, I don't believe, then I take another sample, I send to another lab. In between this period of time, how long have you spent? How long have you wasted? Okay, but as long as once you have an online DGA, I mean installed at your transformer, constant measurement, constant measuring, you'll know what exactly is wrong with the transformer. I mean, of course, that is the benefit of having it online versus offline. Okay? Good? Any question? Other question? You can catch me outside for autograph, it's okay. Are we good? I'm done. No question.
Oke, thank you Mr. Brian. Ya, terima kasih para hadirin. Mungkin ada pertanyaan lebih lanjut terkait dengan DGA online monitoring. Karena kita masih punya waktu kira-kira 15 menit lagi nih untuk sesi tanya jawab. Mungkin bisa dimaksimalkan. Mumpung Brian masih di sini ya. You still here? Ya. Silakan, Pak. Dari mana?
I'm Osa from Pertamina, PHI OSES. Okay, this is maybe other topics than, but it's same. The online monitoring for the transformer. You are already explained about the DGA online monitoring. Is there any product that, because you know the DGA only protect for the winding and the tank, the main tank, but you know the failure of the transformers, mostly the major is in the tank, but 20% or 15% already also in other parts of the transformers, like the buzzing transformers, and then also at the temperature outside, maybe leak, you mentioned. There's another part. Is there any method of online monitoring also for not only the DGA, because the DGA is the 50% part. The other 50% part is outer the tank. Can you maybe share about another online travel monitoring? So to make sure, if because I'm a maintenance, I want to install for our especially the power transformer, because if the travel fail, so I have to buy another one, and then it's take a long time. But rather than I know the condition of our transformer, and then maybe I make a plan to change or to make it redundant, or I have to make a plan before it broken, because before it I have to repair it.
Okay. Of course, today the session is talk about DGA. It is out of the topic. Like other than online DGA, what else we can provide? Of course, we talk about bushing monitoring, partial discharge, all this, the power factor, tangent delta, all this. Yes, we do have it comprised into the DGA device as well. So like I mentioned about the modeling, all this. So if you talk about cooling functions, then you talk about bushing monitoring, all this, we do provide such monitoring, online monitoring. Of course, DGA is one of it. Then it comes to moisture, all this, bushing monitoring, thermal models. We talk about probably there's a hotspot in the winding. So we have calculation on WHST, winding hotspot temperature. Then we talk about thermal, we talk about cooling, we talk about bushing monitoring, fan. All this we do provide for online monitoring. I mean, not just necessary DGA. Then, of course, all this, yes, online monitoring wise, we talk about diagnostic tools. Just now, what I showed to you is all the DGA. But of course, if you want to see polar plot of bushing, it is also same software together. So you can actually see, rather than DGA itself, I can see bushing monitoring. Then of course, I can have models like winding hotspot calculation, everything like wind insulation in barrel, all this is all incorporated in the software. You can actually identify out to the user, to the clients. Of course, if you still remember what I say, one gas, hydrogen, you identify that all fault condition. You must always take into consideration of other gases. Of course, when it comes to, like what you mentioned, DGA, not just DGA, I want to monitor my bushing monitoring. Okay, can you provide like a one-stop solution, one-stop software? Yes, the answer is yes. We can just identify to you at a glance. Probably I want to see bushing monitoring, like probably rather than saying I'll show you a software. Just nice. Where are we now? Jakarta. Very nice. South Jakarta, East Jakarta. Okay, so this is the software that I'm actually talking about. So if you were to see, take for example, where's my mouse? That's kind of slow. So take for example this one. Okay, this is a DGA 900, which is purely DGA. So over here, I can actually identify all the properties, the table, trend chart, which what I've done in the presentation for you all. So you can see very clearly then all the key gas ratio. Then of course, based on your question, you'll be looking at, just give me a while. Just give me a while. I have too many information over here, and the mouse is not listening to me. DGA, you're blocking me. I cannot see. Wait. I'm sorry. You know, sometimes when you don't want to search for it, it always appeared. Then when you want to search for it, it just don't want to appear. You know, this is the system. You know, actually it's at KLPP. Hydrant. Yeah. So over here, just wait for a while. Is it? So this is the gas ratio. Then I want to see models. I want to see partial discharge. There you go. This is the polar plot. Okay, for bushing monitoring. Okay. Then of course at a glance I can have the trend chart. Then I can have the bushing monitoring. Okay. Unless this engineer really studying bushing monitoring, he or she will understand this polar chart. Okay, anyone here understand the polar chart? If you want to go through one session, this will take one whole day. Okay, so of course, like I mentioned, constant monitoring. I have a span of period of time over here. So you can see that actually, this is like what, 2014 all the way until 2016, it's always monitoring. So throughout all the information, all the data is all being collected into this software. So other than DGA, which is very, very important, of course we have bushing monitoring, we have the models, which is over here. Then, there you go. I will have dynamic loading, insulation, aging, moisture in widening insulation, then moisture in insulating barrier, MVA, cooling efficiency, cooling condition, OLTC. Okay, a lot of time I almost forgotten. Inside a transformer, there is OLTC, on-load tap changer. So if you look at probably diverter, selector, okay, for that, the ppm will be a different value compared to the main tank. Okay, will be totally different. Okay, because there is a lot of tap changing ongoing inside. Especially if you are talking about oil field, then you got to jack up the ppm. So at that tank with the OLTC, 25,000 ppm of carbon dioxide, 5,000 ppm of carbon monoxide, that is normal, it's healthy. Okay, it's healthy. Okay, so of course, OLTC, motor torque, widening hotspot, all this are inside the software, which is at a glance, you can monitor everything. Other than OLTC, controlling of OLTC is not applicable for this device. But if you need OLTC controlling, it's under another device, okay, which GE does have it, okay, it's our MS3000, okay. So, yep, I hope I answer your question. All good? Thank you.
Oke, sudah terjawab Pak pertanyaannya, mudah-mudahan bisa ini. Kalau untuk lebih jelasnya lagi mungkin nanti bisa kunjungin boothnya atau komunikasi dengan sales terkaitnya gitu ya. Ini rekan saya mana ini Mbak Nisa? Mungkin untuk sesi pertanyaan dari GE MND kita tutup. Untuk sesi kali ini kita sudahi cukup sampai di sini. Terima kasih atas antusiasnya. Terima kasih. Thank you so much.